Hi, my name's Sean, and I'm a data science manager at Cypherm. We're a company focusing on predicting and improving drug response for all patients. Today's topic is predictive models for clopidogrel response using prescription, procedure, and diagnosis codes. Drug response is very difficult to predict because it depends on a variety of factors such as age, renal and liver function, as well as genomics and lifestyle. In this study, we looked at clopidogrel, which is commonly prescribed for ACS, and built time series models for treatment failure detection and prediction. We used the UK Biobank, which contains a vast array of clinical and genomic data for 500,000 subjects. For our study, we only used prescription, diagnosis, and procedure records. Our cohort was subjects with at least 1 year of clopidogrel prescription and defined treatment failure as having an ischemic stroke, MI, stent thrombosis, etc. within that year. In the end, we ended up with a little less than 10,000 subjects, 1,800 of which had treatment failure events. The figure on the right shows how we processed the data. We gathered all medical records by subject and organized them into visits with the same date. So each subject had multiple visits, and each visit had multiple codes. As for the models, we used gated recurrent neural networks, LSTM, and BERT, and used random forests and logistic regression with bag of words approach as the baseline. We designed two tests. One was detecting treatment failure within 1 year of clopidogrel prescription, and the other was predicting treatment failure within the same window. The main difference between the two approach is that the detection model looks at all the previous medical records up to 1 year after first prescription, while the prediction model can only see up to the first exposure. For the sake of time, I'll only share some results from the prediction task, which bears more clinical utility. If anyone's interested in learning more, please visit our poster and chat with us. The figure on the left shows the ROC curve for the different models. You can see that the time series model, the solid lines, performed better than the bag of words approach, the dotted line. Also, on the right, you can see that having different types of medical records outperforms model built with partial information, especially using sequential models, suggesting that the interaction in multiple modules in structured EHR provides better predictive power. The key takeaways for this study are as follows. We were able to build a predictive model using longitudinal structured EHR data. 1. The time dynamic model outperforms bag of words approach. 2. Incorporating various types of medical records improves outcome. And lastly, medical records prior to drug exposure can predict drug response with high performance. Thank you.